Okay, as we start, this is our Roborama. We are the Dallas Personal Robotics Group, and this is our twice annual approximately contest. And today we have a number of people, and we're competing in 4 different contests. And the robots are from a variety of different, some are kit built, some are enhanced versions of popularly available robots such as the Roomba, and some are more or less scratch built, something everything in between. And today the contests that we're going to run are, the first one is called Quick Trip. And Quick Trip, we drive 8 feet down and 8 feet back. It sounds trivial, but to drive a robot in a straight line takes some skill. And when I say drive, our robots are all autonomous. They're not allowed to be controlled by remote control. So when we drive a radio-controlled toy, we're sitting there watching the robot, and we're able to steer the car or the robot. So we're the control machine, and we're a very elaborate machine. So these are all being controlled for the most part by microcontrollers or little computers. In some cases, we have people that design the robots that are mechanically controlled and don't have computers or have very simple computers. But I think everyone here today, if I'm not mistaken, has a microcomputer on board their robot. So anyway, back to the contest. Our first contest will be Quick Trip, and then our second contest will be line following, which is more or less self-explanatory, where we follow a line, and the robot uses optical sensors. In some cases, I think even here today we have somebody using a video camera to follow the line. And again, the computer is involved in that process. And the third contest will be to drive around a square area, which we have delimited by soda cans. And this is an 8-foot by 8-foot square. And a little bit more complicated than the Quick Trip. You have to drive your robot all the way around the square, and the deciding factor for this particular contest is how close you can come to your start point. So you have to navigate around the square and get as close as possible to your start point. And finally, figure 8 contest, where we will drive around 2 soda cans in a figure 8 or similar shape. And that is also judged by how close you come to the end point. So I guess we will get started, and Ed is going to be our timekeeper for the Quick Trip contest. And again, this contest, you're allowed to touch the walls, but you have to make it over the end zone line, and time is the deciding factor.
Modified Roomba, all the Roombas have a serial port on them, either on the side or on the top, and this Roomba is, I brought the serial cable out to a router. This is a hacked router running Linux. It's a FON router, a special kind of FON router that currently is only available in Europe, that has a USB connector on it. And so the USB is also cabled up to the webcam, which is going to be used for line following, but the webcam is not used on this test. But there is a little light that shows that helps illuminate the line. I haven't tuned this one very well, so it's probably going to bomb out on line following. And the control software is actually running on the PC, so it uses Wi-Fi to pull the data off of the Roomba, such as the wheel encoder sensors, and send it back to the application running on the PC, from where the PC decides what direction and speed the robot should go next, and then sends that command down to the router, which shoves it into the serial port on the Roomba. Does that make any sense at all? Anyone got any questions on it? No? All right.
3, 2, 1 to start?
Sure.
Okay. Make sure okay, 3, 2, 1, go.
I'm not going to be able to complete this course I have a bug that won't send it backwards far enough.
Oh, okay.
Not something I normally do. Let me show it a little bit. Basically, I just took out a little piece of foam board, mounted 4 motors on it. This little blue board on top is a Parallax Propeller prototype board. It's got a 32-bit 8-core microcontroller, and I'm actually only using 2 of the cores. One of the cores running my main program, which basically tells it the motors which direction to go and when to stop. And then another core is monitoring the line sensors, and it updates a global variable whenever it senses that we've crossed a line. And then of course the main program can look at that global variable and know when it's time to come back. The problem I have with this is that it doesn't drive very straight. I mean, there's no steering to it, and it seems to be very dependent upon the surface that it's on. So I'll probably end up hitting the wall unless I get lucky. How many tries do we get to do this?
3 tries.
3 tries.
3 tries.
So I'll do the first one, then I'll try to aim it. It works fine on a 4-foot long course, but when the course gets longer, it doesn't go straight.
Yeah, I'll give you a 3, 2, 1, and then go. Ready?
Okay, I'm not ready yet.
All right.
Okay.
Okay, 3, 2, 1, go. We turn around.
Sure, this is a robot, but I designed it to do the quick trip. It's made mostly out of wood, the wheels and the body. It has an electric motor and gear train that come out of some part of the Chrysler car, I think. And the wheels drive a cam which moves this lever back and forth. And this lever moving back and forth rotates this wheel, toothed wheel, a ratchet. And then on this, that toothed wheel drives this cam, which operates limit switches, which turns the motor on and off. It doesn't have any problem going straight because both wheels are tied together.
Did you hand carve the wheels?
Yeah, well, I cut them out with scroll saw.
That's very nice.
Thank you.
I'll give you a 3, 2, 1, and a go, okay?
Okay.
Okay, 3, 2, 1, go.
Naturally, the robot that doesn't have the computer on board. Probably because of the computer built into the designer, it works better than most of us.
Wow, very nice.
It's a kit you can buy, so anybody can buy this. Basically, the central part here is the little computer, which you can program. It works over Bluetooth, so you can do it wirelessly. On top here, I have an ultrasonic sensor, so I can measure distances. Hopefully, it will see the wall. If it doesn't, I got a bumper to keep it from doing that. And then basically, the motor is using the encoder in the motor itself, so how far it turns, so it comes back at the distance. That's it. Show you the sensor works. Okay.
I'm going to give you a countdown, 3, 2, 1, go. Ready?
Yep.
3, 2, 1, go.
Stop the wall.
Yeah, it's the RGX 2.0. Pretty well.
Okay. 3, 2, 1, go.
Whoa, that's fast.
Yeah.
All right.